Okay, so I'm going to give you the answers to the primes problems in this video. So if you want to know how to do them, you can watch this. I'm going to try and go through this pretty quickly on the theory that you can play it slower, you can pause it, but I will try and explain what I'm doing. So if I was doing these problems, okay, my first method here is prime. Write a method that takes a single int argument, which will be a positive integer, and returns true if the number is prime and false if it's not. So I'm ready to write my method signature. True and false means I'm returning a Boolean. Is prime. It says it takes an int argument. We'll call that n. And so my basic theory here is we need to check a bunch of divisors. The way we check whether something is prime is we divide it, or we try to divide it. And if anything divides evenly, it's not prime. And if nothing divides it evenly up to itself, it is prime. So this is a typical, or slightly typical any. We're kind of asking, is there any divisor? And if there's not, then we just flip it around, or I guess, okay. And we know we can't divide by 0, and we know we can't divide by 1. 0 because it's illegal, 1 because everything. So our first divisor we need to check is 2, and then we're just going to go up by 1. And the comments here, or the problem says, as useful optimization, we only need to go up to the square root of the number. And that's for just sort of a mathematical reason that if there was any factor that was bigger than the square root, it would have to multiply by something smaller than the square root. But it can actually be the square root. So I'm going to say less than or equal to square root of n, and then d plus plus. So this is not a totally normal loop since we're starting at 2 because we're using less than or equals, and we're using the name d instead of I, because in this case d stands for divisor. And so then if n remainder d is 0, that means it is divisible, and therefore it is not a prime number. And if we get through our loop, we return true. So I think, unless I typoed something, oh, and then 1 is not a prime number. And you can see the tests don't check 0 because I said it would be a positive integer. But 1 is just by mathematical definition not a prime number. So I could have put something up here. If n less than 2, return false. But even better maybe is to just say down here, return n greater than 1. So if we got some number that was less than 1, or 1, did I do that right? Yes, okay. So that's very tidy. And in the interest of going quickly, we'll just move along. Okay, number of primes below, a method that takes an int and returns the number of primes. So that implies returns an int. Public int number of primes below. We know it returns an int, not a double, because we're just counting things, and ints are our counting numbers. All right, so again, we'll use n. We're looking for primes below this count. Now, this is a straightforward counting pattern. So we make our count variable, we loop. Now, we could start at 2 or whatever, but because we know nothing lower than 2 is a prime, but it doesn't actually matter because there is prime works properly regardless. And we want to know below, so this is less than n, I plus plus. I is maybe not the best name here, but it's good enough. So if is prime I, count plus plus, so we're counting. And then when we're done, return the count of things. And so, yeah, maybe I'll say limit instead of n. And then I'll use n here just to sort of show that this isn't an index, this is actually a number. We're checking the primes, checking these numbers, whether they're prime. Okay, so that was a straightforward counting method. And the next one is actually equally straightforward, so much so that we can basically actually just copy all this. Number of twin primes below. And the way this was specified, we want to count the number of twin primes with the first twin, meaning the lower one, less than the limit. So we're going to go through the numbers as before. And so the number itself has to be prime, and for n to be the bottom of a pair of twins, that means its twin has to be the number that's 2 bigger than it. So like 3 is prime, and so is 5, and so they are a twin pair. And so that's what we're counting, all the n's where it's the bottom of a pair. And so all I did was add this clause, this and clause, to my condition in my if. And, number of twin prime pairs. Gotta name the method right. And there we go. All right, and then is super prime. This is going to be short and sweet. This was maybe kind of a trick question because it does not require a loop. The point is we want to know if some number is super prime, returning a Boolean, and the definition of super prime is, so for some, now we're actually talking about some particular number n, it's prime, and what does it say here? So prime numbers whose position in the list of all primes is also prime. So also is kind of another way of saying and. So it's prime and also is prime. And so what is its position in the list of primes? And I give some examples here. So like 2 is at position 1 because we're using normal human counting, not programmer counting. And 3 is at position 2 because 3 is the second prime number and so forth. So another way to look at that is it's the position of any prime number in the list of prime numbers is the number of primes below that number plus 1. Right? So there's 0 primes below 2, but 2 plus 1 is 1. There's 1 prime below 3, 3 plus 1 is 2, and so on. So this is actually just a Boolean expression. N is prime, and so is the number of primes below n plus 1. And so if that's true, the number is super prime. All right, and so that is it. So if you are going to take the retest on Tuesday, these are the methods you should be able to write. There are other ways to write them, though these are pretty simple and clean. And so as you can see, we banged these out in just a few minutes. So hopefully you will be able to as well.